My name's Adam, and this video is showing you how to write scripting to automate view orientations in 3-matic. Automating view orientations may seem kind of trivial or not needed, but can really make a workflow more seamless in terms of the user interaction by automating the view that the user needs to view certain parts or to make selections of certain objects a little bit easier. It can be used in virtual surgical planning sessions, so that if a surgeon would need to interact with the software, that they are not fumbling around with trying to reorient the view in 3-matic. As you may know, when you hold the mouse in the middle of this screen and you right-click, you can rotate the object, but new users will frequently put their mouse on the edge of the screen and try to rotate, and it doesn't work because it's doing a clockwise or counterclockwise rotation with respect to your view directions. So that can sometimes fumble up new users. Also, if you're doing a high volume of cases and you're doing some repeatable type actions, that's just asking to be automated. So it can be helpful to automate the views to just speed up workflows as well. So for this example, I'm showing a skull, one of the demo files from Materialize, and in our Visual Studio Code, this is essentially what we're doing. The first step that you want to use to automate a view is to have the user set an AP view, or anterior posterior view. I show in a previous video, which I'll link to, a way to kind of reset your whole anatomic model that orients with the world coordinate system. So basically this orientation here, but most people aren't standing perfectly straight up in your world coordinate system. And if you don't want to reorient all of the anatomy to a world coordinate system for a bunch of files, it can be a little bit easier to just have the user set an AP view at the beginning of a workflow. And then any custom view that you want afterward can be calculated based off of this view. If I say like, this is my perfect AP view, you'll see that if I do trimatic.getView in the console, what you get back is a list of two tuples. So you have the first tuple is coordinates of the vector that goes into the screen, directly into the screen. And the second tuple is the up direction. So what's straight up on the screen. And so you see it's pretty close to 0, 0, 1, but it's not exact. That would be the Z up direction. And into the screen, you can see it's very, very close to 0, 1, 0. So that's a perfectly y-axis is directly into the screen, as you can see from this coordinate system here. So what we can do is, in this block of code, we set that tell the user to set that AP view. This AP view, as I show those two tuples, we break that up into the view vector, which is the first tuple, which is this with the index of 0, and the up direction, which is the second tuple, which is AP view 1 here. The next thing we do is we figure out what do we have to add to those views to make them rotate into, say, a perfectly sagittal view or perfectly axial view. And so we essentially have like offset values, or what is the difference between a perfectly sagittal view and a perfectly AP view? Well, you rotate it by 90 degrees, which is this here. So essentially, if I imagine my AP view was perfect, you'd have a 0, 1, 0 and 0, 0, 1. And if I add this to the view vector, the first tuple, then I will get a 1, 0, 0, which rotates, so my x-axis would be into the screen now. So that would be a sagittal view looking at patient left. And my up direction is the same, so I don't need to do anything. Then if I wanted to, say, do an axial view, that view vector becomes, it switches the z value. So now I have like a 0, 0, 1 that is my view vector. And based off of the original view vector, which is 0, 1, 0, I have to add this to it to get it to be 0, 0, 1. So those are kind of like offset values. So it's like, what do I have to add to my original AP view to get it to switch to custom view. And you'll see that the axial view, the direction changes of the view vector, and it also changes for the up vector. So the up vector becomes, let's see, what does it become? My up vector becomes like a -1 for y. So that's why here, if we add this to the original up direction is 0, 0, 1, if we add this to it, it becomes 0, -1, 0. And that's our new up direction. So that's fairly straightforward for these orthogonal views. But let's say I want a real custom view that's kind of a random position or not one of the X or Y directions. Then I want to be able to pull the custom view from this program. So further on down the line, this is essentially calculating what are my new view vectors and up vectors using these offsets. And then when I want to actually apply that view, I put in those calculated values to make it perfectly sagittal in this case, or perfectly axial in this case. So I'm just kind of with this zip function, I'm just summing together two tuples, the original view plus the offset, and that gives me the final for the view vector and the up vector. This basically says first you want to do this kind of operation, a plus b, for a and b in zip, and this will be the original vector, and this will be the offset value. So I'm summing together an offset plus the original. And that gives me just the view vector, and then for the sagittal, up vector was the same. For the axial, we had the up direction of axial change. So let's try and run this for this maxilla now. So first has the user oriented to AP view. So I'm gonna level out this. I think that looks pretty good. When I click it, the sagittal view is then used, and then axial view is then used. So I was able to do 2 additional views based off of my initial set point. Now I have this option here. So if you want to make your own custom view, you can put it into whatever custom view you want. So let's say it's a what do we call it? Trimetric view, something like this. And then I could click OK, and it will provide me some offset values, and I can go take these and plug them into the code that I have right now. So that was the first printout is the view vector. So I can just paste that value here. So I have to do a right click, copy, paste here. And then it gives me the new offset for the up vector here. Just paste that in here. Okay, and then just uncomment these. Uncomment these. And I'm going to comment out the sagittal view and uncomment this custom view. So this is using those custom values that I just got from the log, print log. And here's my calculations to calculate a new view vector and up vector from the originals. And then here's the custom view setter, which basically puts the results from those calculations in there. So if I save this and run the program again, I'll set my AP view originally. just like that. And then there you see my custom view. So not sagittal anymore, and that's my custom. So that would help you if you wanted to write some code where you didn't really know how to like set that custom view. Now you can do it pretty easily by just having some printout values and paste them into some code, so that becomes a lot easier. Or if you need to do it for a lot of different models, this will work for everything because you base it off of initial user set view. So yeah, so all right, so that is how to set some custom views. All right, thanks for watching.